Yeah. Welcome to IoT Users Club. And today we have a session on IoT and blockchain where we have our speaker from Verizon. So Rangesh. So Rangesh Sripathi is a blockchain architect at Verizon, and he has a very good experience on Ethereum and Hyperledger Fabric. And he will be hosting our session on how IoT meets blockchain. So how we can see whether the IoT and blockchain how we can integrate together and come up with some use cases. And Rangesh has completed his bachelor's from Sri Venkateswara University, and you can connect to him using the LinkedIn profile which I have shared with you. Yeah, Rangesh, welcome, Rangesh, and you are the host now.
Hey, thank you. Thanks for the warm welcome. So, to get started, right, I'll introduce you. My session would be more towards blockchain and how you could leverage blockchain with IoT. So, with that said, I'll introduce myself. So, I have been with blockchain for more than 3 years, and I have worked with different frameworks like Ethereum, Hyperledger Fabric, Sawtooth. So, in this session, I'll give you introduction about blockchain and then how you could leverage blockchain with IoT, and then use cases that are in the market that leverages IoT plus blockchain, and then we'll see a demo of seafood traceability with Hyperledger Sawtooth. And so this being an hour session, I'll give you a very basic intro. Maybe in series of session we could cover more in-depth topics. With that said, I want to share my screen. Right. So I assume screen is quite visible to all. Um, so let's get started. So this is the agenda that we will go over. So introduction about blockchain value add-on to IoT, and then use cases that leverages blockchain and IoT, and at last sample use case on food traceability, followed by demo, and then question and answers if any. Uh, yeah. So let's get started. So what is blockchain? How what are all the properties of blockchain, and what are different types of blockchain that exist in the market? So what is a blockchain? This has been quite this has been quite and it has been emerging technology that has been often used for at least for the past 2 or 3 years, and I would see more right towards blockchain. So let's get started. So what so I'm and so let's get started with blockchain. What a block is? A block is something you could define. A block is nothing but a transaction. A transaction is nothing but as a record. Okay, a record that is transformed after applying a business logic. So a block that cannot be altered, right, is defined as a block here. And then once you take the chain, right, it is all different blocks would be nested together to form a chain. So when I say blockchain, it is going to be my records nested such that at any point of time I could go back and see, um, I could go back and see what happened to my transaction. So in blockchain, you could only insert. There would be no update. Even if you are going to perform update, it has to be a subsequent insert. So ledger, ledger is more of like a database here. So there are when it comes to different framework, right? Different frameworks supports different version of ledgers. Quite familiarly with blockchain, uh, the level DB, couch DB, NoSQL DBs are quite often used rather than relational DB. That's the reason, you blockchain got to deal so much large amount of volume of data. So they support, you know NoSQL DB. Most of the familiar blockchain uses NoSQL DB, and then the important characteristics, it's the decentralization that distinguishes today's system with everything else. So what is decentralization? This is the important aspect that everyone should understand if we got to kick into blockchain. Decentralization refers to it's not one owning the database. It's it's everybody owning the database. It's not you. So for instance, if I'm going to spin up a blockchain network, generally it you know it will be only one organization who's going to own the database. But when it comes to blockchain, it is going to be partner, or it is going to be parties who are involved in that blockchain. So it's everybody who is going to own the database. That's the one best thing that blockchain has brought to. So it is decentralized, so not one organization. For instance, if you take Google, Google is going to own the entire database. Google is going to own all your data, right? So once you come to blockchain, it's everybody, right? You can, again, it can be private, it can be public. So once you talk about public, everybody could see everything what's happening in blockchain, and it's not owned by single organization. That is the only biggest feature, that blockchain has brought into the system. Now comes the consensus. So when I say it's not going to be one database, it's going to be split across, it is going to be distributed. You got to have an efficient way of writing record into your database. So that's where consensus comes into picture. Consensus is, in simple terms, consensus is nothing but, when I say 1 plus 1 is equal to 2, so this operation or this transaction will be executed in all of the peers. Okay. So and then once it say 1 plus 1 is equal to 2 in every node in which the blockchain is involved, then the record goes and stores. That's called as the consensus. And then immutable. This is one of the very important feature. Immutable. What does immutable mean? Yeah, you cannot tamper it. It is tamper proof. Correct. So in blockchain, every record is an insert. Even if it is an update, it has to be an insert. You cannot just like that in your relational database where we go and just do an update, right? So that is not possible in blockchain world. Next comes the important feature, something called as smart contracts. So smart contracts are, a piece of logic that is going to get executed in different nodes. So this is you could write all your business logic. Enterprise application have different business logic. So that's where smart contracts fit into. So this is more of like a piece of an enablement for blockchain to write your business logic. And then provenance, this is again one of the important feature. So if you got to track anything, or if you want to look, okay, see, you go and purchase some food in supermarket. So if you want to look through, okay, what has happened, from where did this come from, from which, if you just scan through some QR code, and if you want to look from where the food is, what is the origin of the food, you could still go and do it. And for that, right, blockchain is one of the best technology. You could go and always track what happened to that asset at any point of time. This is all mixed up with properties, different properties of blockchain, like immutable, smart contracts. So to sum up, right, a blockchain will always possess three important features. Number one, it is decentralized. Number two, it is immutable. Number three, the trust that is coming out of from the immutability and decentralized characters. So this is all about blockchain. In this is in a quick session that I'm covering. So these are all important characters that defines what blockchain is about. With that said, um, I would like to bring, what are all the types of blockchain that exist in the market. And you got to differentiate between decentralized versus centralized, as well as distributed ledgers. Okay. So centralization is something every only single organization is owning your data. Decentralization is something where everybody owns everything. This is substantial power that we take out from the centralized system. So assume, like, all your data being stored by one single organization. Now probably if one single organization gets hacked, gone, your data is gone, right? That is not the characteristic when once you bring it to decentralization nature, because the data is getting distributed and no single entity or organization owns that data, but instead all of the organization that is participating in the blockchain network owns the data. So that is one single property of decentralization. The reason that I'm stressing out decentralization is, you know, folks get confused with distributed. Hey, see, I have MongoDB, I have Cassandra DB, so it is distributed. So does that qualify for a blockchain? No, it is not. The reason is, even though Cassandra or MongoDB is distributed in different region, it is still owned by one organization, right? So when you talk about blockchain, it is not owned by one organization, but it is owned by the participating one or more than, no, it's not only just one organization owning the data, but the participant who wants to participate in the blockchain network, it's not one, it's many, or whoever is joining that network owns that data. So that is one of the important feature that I would like to stress upon. And I would like to distinguish between centralized and decentralized nature, and this is one of the important characteristics. Now, when you talk about the different types of blockchain, right? There are You could classify blockchain into two types. One is public blockchain, another one is private blockchain. So when you talk about public blockchain, user are anonymous. For instance, Bitcoin, Ethereum, and all those cryptocurrencies, right? You don't know who's the person making transaction, but you know what amount. If Rangesh stands for $10 to Satish, you could track that in the public blockchain, but you don't know whether Rangesh and Satish did the transaction, but instead you could only see the amount. The user anonymity is guaranteed once you take about public blockchain. And anybody who is participating in that organization, in that public network, can go and look upon the data. Quite opposite to this is the private network. you know this private network is of enterprise, or enterprise interest, enterprise organization like Google, Facebook, Oracle. All the big enterprise companies, right, are interested in private blockchain network. So here, they form a consortium. So what they do is, like, they go talk to different people of similar interest. When I say different people, different organization of similar interest. um, one such use case is, you could probably take uh, the telecommunication network, where Airtel, Geo, Reliance, all could form a telecommunication consortium, and they could run their own private network. So what they do is, like, they don't allow everybody to enter into the network, but they only allow folks who they want to. That's called as the private network. So to sum up, public network is something everybody can onboard, anybody can onboard. There is no restriction. In private, it is of enterprise interest, and only known folks can join the network. So with that said, right, so I'll walk you through. Um, yeah, I'll walk you through the frameworks that are available to achieve public and private blockchain. So public blockchain, you have Ethereum, Neo, multi-chain. Like I said before, Ethereum is quite famous for cryptos. Neo is alternate version of Ethereum. And then when I talk about multi-chain, it is very good use case for asset tracking. And now comes the enterprise interest private blockchain. You have Hyperledger Fabric, you have Hyperledger Sawtooth, you have Quorum, you have Coda. So all these are different frameworks that support private blockchain, and that is of enterprise interest. So what folks do, enterprise folks does is, they form a consortium. And they write rules with smart contracts, and then write rules in smart contracts, and they execute their business logic. That's where private blockchain is into. With that said, One important stuff that I would bring upon is, um, hey, see, you told me what blockchain is. You told me what types of blockchain is, but tell me whether do I need a blockchain, right? And what kind of blockchain do I need? So this flowchart, right, mm, would really help folks. So the first question that you got to ask is, do you need a shared database? If it says no, then obviously you don't need a blockchain. So if you don't have anything to do with database, then you don't need a blockchain at all. So and then do you have trusted third party? Okay, so when you say a trusted third party, it could be any organization, like Visa, Mastercard. All these are trusted third parties. If you could trust it, yeah, then you don't need a blockchain. And if you don't trust your third party, then you come to this flow. All writers to the database node. If you say yes, can you trust all your writers? When I say writers, those who are operating in your database. If you do trust your writers, then you don't need a blockchain. So if this question is no, right, you distinguish between private and public permission blockchain. And then if you again look into if you don't know who are all going to write to my database, then you must obviously go to permission blockchain. So permissionless blockchain is nothing but your public blockchain. So this flowchart can be referred upon at any time, and this is out there in the internet. So if you want to um, you know choose the right blockchain, or if you want to know whether you need a blockchain for your use case, I would strongly recommend to go through this flowchart, and decide whether you need blockchain or not.
Hmm. Yeah, that flowchart is very nice, Rangesh. So this is really very nice whether we should go for a blockchain or not. So if we
Mm.
trust all the data, all the third parties and everyone, then there is no need for a blockchain. This is apt.
Yeah, yeah, exactly, Satish. So
Yeah,
yeah.
a good one. This flowchart is very good, Rangesh.
Yeah. And then, yeah, so this is I think I covered this. So the popular frameworks that exist for the public and blockchain. These are all my recommended version of public blockchain and private blockchain. All these are frameworks. So once you go back to one more slide, right? So quite no, those who are beginning in the blockchain, right? They would be confused. Hey, so should I implement all this crypto? Or should I implement all these stuffs by myself? The answer is straightforward, no. All these are there. So all you got to do is you got to understand what blockchain is and what are all the properties are. Once you do that, the frameworks that I listed here, right, does the job for you. So that is one of the important no that is one of the important question that I often come across. People ask me like, hey, so should I implement my own crypto? Should I implement immutable features? Should I write some functions around it? The answer is no. So everything is there for you. So all you have to do is choose the correct framework and probably play around with it. So everything is ready. It's ready built out there. So you just got to download the libraries, and it's quite handy. Like we play around with Java or C sharp or whatever language it is. So that is one important step that I would like to stress upon as well. So I'd like to take up any questions, Satish, now, because before I dwell into IoT and use case.
Yeah, there is one question, Rangesh. So from Azmatullah Muhammad. So he is asking. Just now you have highlighted whether coding is required, or coding programming knowledge is required or not to learn blockchain.
Right. Uh, okay. Uh, yes, Mohammed. Uh, so you know, the coding would come into picture at only one point. That that interception point is here. The smart contracts. The smart contracts is the only part where you write your business logic. So we got to suffice the business logic, right? The business logic is going to differ. Um, the business logic is going to differ per enterprise, per the company's need, correct? The domain need, domain understanding. You could fit all your coding or stuff only in smart contract. So if you ask me, how would smart contract look like? It is quite similar, all the popular framework that I listed out right here, right? Let me go back. Yeah, the multi-chain, Ethereum, Neo, Fabric, Sawtooth, Quorum, Corda, right? Corda plays with Java. Quorum does with Solidity, and Ethereum does with Solidity again. So Solidity is quite similar to JavaScript. So if you know JavaScript, right, you could obviously get started. So it's quite easy. I mean, if you know JavaScript, you can get started. And once you talk about Fabric and Sawtooth, they do it in Go and Rust languages. So
Yeah, and I think we have from Jayant Chandru about the resources. I think you share the resources at the end of the session, Rangesh.
yes, yes,
Yeah, I
sure.
have to. And we
Yeah,
have some question from Arvind. So he want a demo for Ethereum. So I don't know whether you have planned on Ethereum. I think you have planned on Hyperledger, right?
yeah, I have planned on Hyperledger Sawtooth.
Yeah, so we will cover the in the next session, Arvind. So about the addition of block in Ethereum. So we will do the demo in the next session because this is a starting session. So and Rangesh promised that it will be a short and sweet session with introduction to blockchain and IoT. And in the upcoming sessions, we'll be covering Ethereum, Hyperledger, and IOTA as well.
Yeah, that's correct.
Yeah, go ahead, Rangesh.
Right. So let's come to IoT actually. So the folks out there should be, since this being an IoT meetup, so folks out there should be familiar with IoT, though I'm not that much. But so all these IoT devices is going to send humongous amount of data, be it to any of the system. It is going to be captured in your database, right? So I pointed out that blockchain is decentralized and distributed. This meaning that this means that the data is not going to reside in one centralized database, but it is going to be spread across different entities. So this will eliminate the centralized failure. So if you're going to host it in one centralized database, and if your network is going to fail, you're gone, right? So once you come to play a blockchain network, that is not the case. It, because the nature of blockchain is decentralized and distributed. So there is no single point of failure. Now comes the second beautiful point, that is the provenance and traceability. Since the nature of blockchain is immutable, right? So if I have updated a record, you could you could go back, look through what happened to that record, right from the scratch. You could always go back and look, hey, what all happened to my record, what are all the different transactions that happened. You could pick at any point of time, if there are 10 transactions that has happened to this, you could always go back right from 0 to 10. You could go back and look into what has happened to that transaction, right? That is one of the single best feature. Plus all of them are immutable, correct? That is one of the best feature. And then the trust, you know there you need not have, if there are two parties, if Oracle wants to, if Oracle wants to talk, if Oracle wants to give the data to other system, like um, to other let's take an use case, where I want to exchange the data. For instance, there is a logistic company, who wants to exchange that data to a different company, right? Ideally, you would need an intermediary, because the company who is accepting the data would not trust it. But once you take the case of blockchain, they both are connected peer to peer. There is no require for intermediary. You could just directly transfer the data to intended participants. And then you have the smart contract, who is sitting in the middle. Once you get the data, you could do all your you could do all your business logic, and all of those again are secure plus immutable. um, you know that is one of the feature which could definitely add value to IoT, because a lot of data, lot of data would flow in from sensors, right? So this being distributed, and there is no single point of failure, and you have the capability to trace and look through what has happened to your transaction at any point of time, and you could still go and have exchange data without any third party intervention, right? I see that all these features, right, is quite bigger value add on to IoT. With that said, all those are theory, right? Hey Rangesh, show me, show me the money. Okay, so what, who have done what, so this is all the use case that I am displaying, right, are all into production, and these folks are using it. One such use case is Ever Ledger. So the diamond tracing is one of the important topic, because there are frauds happening once you talk about diamond, because you don't know from where it got originated, and there is quite black market as well around that. So there is an organization called as Everledger. What it does is they probably deal with Kimberly diamonds. I heard that these specific variations of diamond are quite costly, you know so what they do is they write from the origin, right, from where they mined. Okay, they are tagging that diamond in the blockchain. So if you go to everledger.io, right, you could probably go and see, at what place was the origin, at what place was the laser cutting done, at what place was the manufacturing done, at what place did this diamond get sold. And if in turn this diamond is going to come back to the market again, they would easily just scan that and see the entire history, right, from origin, who's the owner, who's the manufacturer. This way, right, the blockchain is quite handy, uh, handling fraud cases and dealing with diamonds. So this is right there in the market, Everledger. And then next comes the interesting use case, use case on Net Object X. So they are using IoT sensors for smart car parking solution, and they have, they are using cryptos to do the payment. Once you could park your car with smart car parking using IoT, and then the money gets deducted automatically using the crypto. When I say crypto, it's they are doing with Bitcoin. Then next comes the screw chain. You know, the screw chain is again for food traceability. These, the screw chain, right? They mostly deal with food supply chain. So, they have several products like coffee, fish products, seafood products, and then coffee beans, and then meat. They what these guys are doing, skill chains have formed a consortium with different vendors, and they are right from origin, right, from where they are getting this product, from which uh, area, land of scope did the coffee beans come into, and right from going to the distributor, right, reseller and distributor, they are capturing this in the blockchain. They are tracing out for the safety, for the safety of end consumers. So the consumers, right, they could always, they could see QR code, they could just scan that QR code, and now they are able to see, okay, this product has come from this origin, and this is the distributor, and this is the reseller, and this is where I brought this from. you know and again, screw chains are into production, and there are variety of supply chain management use cases, right from healthcare industry, food traceability, automotive industries, and everywhere. Blockchain is actually in production mode. I'll take a pass here. If there are any question, I like to answer it before we dwell into our example.
Yeah, yeah. So we have something from Yugendra. So he's asking how we can secure different IoT nodes using blockchain. So this is, I think, you will be covering at the end of the session, I think.
Uh, okay. Um, see, the IoT nodes, um, the blockchain as such, would not give you any protection to your IoT nodes. I'm not quite clear with the question, Satish. So, see, the IoT
No, I
nodes in the
think
sense, yeah.
no, Rangesh. I think this question will address once we complete the session. I think you have the
Okay,
answer in your session. I hope so.
okay, all right.
Yeah.
Okay. Um, yeah, so this being an intro session, right? So I've picked up familiar use case just to understand or ease out the audience. So let me play a video here. Let me know if you can all see.
Do we have any audio for this video, Rangesh?
Yeah, yes.
It's yeah, it's not audible.
Oh, okay. Uh,
I
maybe I
think when you
can. Yeah, go ahead, go
or
ahead.
others, you can just have the
Summarize
prompting
it.
over. Yeah.
Yeah, or maybe I'll turn on the subtitles for you folks. Right, I like to take a pass here.
Hmm.
So if you look at this food supply chain, right? So if you want to dine out and if you want to have some food at the restaurant, in this case it is the fish. Okay, it is the tuna fish. Tuna fish is quite costly, and there is a quite demand for it. So again, tuna is specific variety of fish. Um, so if you look at this supply chain without blockchain, there are so much of intermediary you see here. The first one being, somebody, a fisherman, commercial fisherman, um, buying a fish out there. Okay, now he's catching those fishes, and then you have an auction broker who is an intermediary who buys all those fish, and then you in turn have one more broker here who again buys that and then sells that to the distributor, and you know and the end of the day it goes to the restaurant. Of course, you have the cold storage, where you preserve the fish for n amount of time. Okay, this is the problem without blockchain. It goes through several life cycle, and once you go and dine out, you pay all your money and you want to have the tuna fish. You don't know what is the real state of that particular uh, fish once you go to the restaurant. Okay, that's the problem that this talks about.
So this is about tracking the fish what he is eating in the restaurant, Rangesh.
Yes, exactly, exactly.
So maybe the same test case with the diamond one, which you have said about the diamond
Correct.
implementation.
Exactly,
Yeah.
exactly. Can you see the subtitles out there,
Yeah.
Satu? Yeah. Okay.
Yes. And you can narrate the story if you want.
Yeah, yeah. I'll do that.
Yeah. One thing I want to ask Rangesh. So we have a lot of flavors in Hyperledger. So can you just
Yeah.
elaborate which one we need to use for which thing after this video at the end of this video?
Yeah, yeah, sure. I'll take a break. I mean, in the next slide, right? I have covered the
Hmm.
same, like what stack I'm using.
Okay.
Yeah.
Yeah, this is a nice use case and nice video, Rangesh. I think we can apply the same use case for all the supply chain
Supply
management
chain
products.
management.
Yeah.
Yeah, exactly. Exactly. Yeah.
Yeah, go ahead, Rangesh.
Yeah. So just to sum up for folks who are sorry, I mean, I was not able to provide the audio though. I'll just narrate the story. You know, Rich is a guy who owns the restaurant. He wants to earn the trust of the customer because he don't want to forge the customer saying the they have ordered for tuna fish and he don't want some other fish in the plate. Okay, so he wants to earn the trust of the customer. And right now, right, like I mentioned earlier, there are different once the tuna fish is hunted in the sea, there are various it takes various path before it reaches the restaurant. So and then this particular, right, this particular case is a problem for Rich, who is the restaurant owner, because he cannot provide trust to the folks who are visiting the restaurant. Plus he also wants to earn the trust of the customer, and he don't want to forge anything, right? So this being said, right, so how is blockchain, how is blockchain solving this is, of course IoT is being used here. So the assumption is, once the fish is caught, they would have a tag with IoT sensor enabled. and that could track, all of the temperature, the preservance. Your fish should not get spoiled at any point of time. It could tag the location, temperature, and it could send all this information periodically to blockchain, and then we use all the properties or characters that I explained you earlier. And then once folks are trying to dine out in the restaurant, right, they could say, hey, this restaurant, um, is a legitimate one, because you have tracked, the food that is coming into the restaurant. So in this case, right, the IoT being the data provider, you know IoT sensors being the data provider, where it continuously sends the data of tuna fish, where it is located, where it is being transported, and who are all the different vendors buying those. And it enables, like a data provider. So that being said, this is the summary of use case that we would do with, with the demo going forward. So this is the use case. I assume like folks who are listening are quite clear with what I'm covering, and I'll go through the stack and demo in a short while from now. If you have any questions, let me know before we jump into the demo and then covering the tech stack. Okay. Um. So yeah. Hmm. Right.
Yeah.
So the
We
stack.
have a question, Sandesh, yeah, from
Hmm.
KMJ.
Yeah. Go on.
Yeah. So if wrong data goes into blockchain, as a blockchain is a ledger technology, so what mechanisms or steps can be taken in order to rectify the data?
You got to update it. It's just key value pair. You have primary key, right? So once the data is gone, that's the beauty of blockchain, right? If you say, if you're going to insert wrong record, you take the responsibility. You cannot tweak it saying, hey, I unintentionally inserted wrong data. No, this is not I what inserted. So to answer, your question, if it is wrong data, you got to subsequently insert one more. It's
Yeah, one more.
periodic update. Yeah. So see, that's the
And
beauty. You could see that is one of the beautiful nature of blockchain. Once you talk about centralized database, you could go and update it. Correct?
yeah,
You cannot do that here.
yeah, and we have some question from Shubham Gupta. So he wants some ideas for implementing blockchain in hospital management system. So does anyone working on this? Do we have any ideas which you can suggest to Shubham Gupta?
I would need more inputs, like hospital management. I think there are different parties involved in hospital managements. Uh, you
Yeah,
know,
Shubham. So I will address this one. So Shubham, so one thing is, so first, whether you need a blockchain or not, you need to decide that one in the hospital management system. So if you see the flow chart which Rangesh has shown, that is a good one, whether we should go to a blockchain or not. So at what perspective or what data you should secure it. So you need to think about those flow chart and then decide whether blockchain is required for hospital management system or not. So that is the first thing. Next, if it is required, then I think the coming slides will tell you how to make the data secure. So, which Durga is also asking about how to secure the data. So, in the coming slides, we will show how to secure it. So, what are the procedures? What are the security CIA triad, confidentiality, integrity, availability. So, these are the three security triad. So, which we talk in the perspective of security. So, we will address that one in the coming slides.
okay. Thanks, Satish. Okay. So I think,
We have a question. We can even track the fish without blockchain from
sorry,
Kadal sir.
sorry. What is it?
We can even the video which you have shown for the fish tracking, right?
Yeah.
So he is asking we can track the fish without blockchain. Is it not? So that is obviously yes. But if you want security and if you want the new technology, then we should go with the blockchain.
And one more point is, see, you have distributor, right? So say,
Yeah.
to answer Kagar question, right? Um,
Hmm.
so see, who's going to own that, right? That is one of the questions. See, you need distributor, you need the manufacturer, you need the seller, the manufacturer, the owner, right? All there are, where once you talk about supply chain, right, you go, the person who is hunting the fish is one participant, okay? The person who is going to get that fish is second participant, and the person who is going to get that from the market or the restaurant owner is third participant. The last comes the customer, right? So you have four participants in this use case. So assume like, who's going to own, once you say you can do this without blockchain, yes, you can do this without blockchain,
So
but
for
tell me like,
Rangesh, just I would add it here. So for normal fish, blockchain is not required. Since it's a tuna fish, blockchain is required to track its all the
origin,
supply chain management. Yeah, because
correct,
it's costly.
exactly.
Yeah,
Hmm. Yeah, that is one thing. See, if you're not doing, if you're not putting those in the blockchain, right? So presume like somebody, I'm in the black market, okay? So I would come
yeah,
and give a fish. I would come and give this fish saying, hey, this is tuna fish, and I could only give you the meat saying, hey, I got this from whatever ocean it is, and then I could claim this is tuna fish. How would you prove it? Right? How do you say that, hey, no, this fish came from this ocean and this guy hunted it? And how do you do that?
yeah, yeah,
Correct,
yeah.
you
Yeah,
don't
since
have.
it's tuna, we need the technology. For other fish, not required, Rangesh. Yeah,
Yeah,
yeah. Go ahead. Yeah.
yeah. I think I mean that's a valid question though, but the purpose is, you got to prove that it has come through this cycle. Okay, see, anybody can forge it, right? See, restaurant owner need not buy it from, it cannot come from the point of origin. He could have brought it from anybody, right? How do you prove it?
Right. Yeah. Yeah.
Right. With that said, do we have any more questions, Satish?
I think so. What is Sawtooth and Sawtooth Lake are same? So this is one
Yeah,
question
it's,
from
it's
me.
yeah, it's quite similar, Sawtooth and Hyperledger Sawtooth Lake are similar. The initial version of Sawtooth came with Sawtooth Lake. That was, the intention was to uh, dwell the Hyperledger framework with supply chain alone, but then, you know, this can be leveraged with different use cases. They modified it to Sawtooth. There's no difference though.
Yeah, go ahead, Rangesh.
Yeah. So the demo that we are going to see, right, would be on this stack. I have used Hyperledger Sawtooth, and the consensus mechanism is proof of elapsed time, and the environment that I have hosted is into Ubuntu EC2 instance, and I've used Docker, and front end is Angular, and the components are validator and transaction processor. I'll let you know what transaction and validator are. So typically, right, Hyperledger Sawtooth has two common components. One is validator, and another one is transaction processor. So validator, validator, once you get a record from your client side or from your external system, you expose an API, and then the data is fed into validator, and then inside validator you have small functions called as transaction processor. So that, that this is what we call as smart contract. So they absorb the data, and then they do whatever logic you want to perform. So if you want to do whatever business logic, okay. So if in this case I just want to track it, nothing else, correct. So I'll just track from who owned this, correct. So that is my business logic here. So try TPs, right? It's often called as TPs in Sawtooth. Again, I'm not going in depth of Sawtooth. This being an intro session, I want to ease out the audience. Um, So you have TPs that is responsible for running the business logic. So you have something called as validator two. These are different participants. In our use case, we had distributor, reseller, the restaurant owner, right? So they got to form a consortium and they got to have their own validator. So one guy, one restaurant, one party cannot be single owner, because that will again violate the policy of central decentralization. So all the restaurant owner, the manufacturer who caught the tuna fish or the point of origin, plus who is the distributor, right? They all got to form a consortium, and they will have their own validators. Okay, once the transaction is flowing into validators, the transaction processor that is sitting in this validators will execute the transaction and broadcast it to different validators. Now, once they get the data, they also execute the same logic and ensure that they get the same output. See, this is very important character of the smart contract. Let me reiterate. So, validator one is distributor, validator two is, I'm just taking out an example, okay? Validator two is manufacturer who caught the tuna fish. Okay. Now validator two will say, hey, I caught tuna fish, and he will say these are all the latitude or longitude, or these are all the data points. Who caught this tuna fish and what is the name of that asset. Okay. He will send the data. Now upon validator one receiving the data, the same logic will be executed again to ensure that you get the same output. Once you reach the consensus, the data will be committed into the blockchain. Okay. So even in simpler term, let me say this. If you are going to have some logic in transaction processor that just does addition of two numbers, once you pass an input, the transaction, right, the addition of two numbers will be executed in validator 1 as well as in validator 2. Okay, in both the validators the addition of two numbers will take place, and it will match whether it got the same output in validator 1 and validator 2. If it says it is of same output, the record will be committed, else the record will not be committed. The record will be flagged as invalid transaction. I hope this is clear, okay? Because this is the important property of uh, smart contract. So what? So the number of the logic will be executed n number of times, which is equivalent to n number of participants. If I have four participants, and if I give an input to to any of them, the transaction will be broadcasted to all of them, and all of them will execute that and ensure that they all get the same output. If there is you know if there is different output, that means the transaction is forged and there is something invalid with the transaction, and the record will not be committed into the blockchain. Okay.
Yeah, fine.
Yeah. Okay, with that said, I'll quickly jump on to the demo. So I hope you are able to see my screen. I'm just switching it to my uh, city instance. I just want to show you few components before, um, right, before I jump into the um, you know before I jump into the UI. I just want to show you a few components. Let me do this real quick. I think we are running short of time as well. So like I said, you right. If you look at my presentation, you have REST API, you have transaction processor, you have validators. So if you look at this, right, this is the sawtooth REST API which I have exposed. This is the uh, transaction processor, and again this is the these all comes with sawtooth. Okay, so this is the tuna chain, which tracks what happened to my tuna.
Yeah, can you
Okay,
increase the font size, Rangesh?
sure, I'll do that.
Yeah. Change settings, change settings,
Hmm.
change settings. Above, yeah. Go to appearance. What is there? Yeah, just 820. Okay. Yeah.
So I have run the sawtooth. Sawtooth uses Rust language, and so if you look at this, right, so I have my validator, sawtooth validator, that is responsible for accepting all of my transaction, and this is exposed via the validator is again exposed via REST API, and I have my transaction processor, um, which takes care of upon receiving the data, what is the business logic I got to execute. That is all nested into sawtooth tuna chain transaction processor. And then you have the tuna chain client. This is the front end client that you see right out here. This is with Angular. So everything is exposed as um, the Docker service. So I will share my code and stuff to Satish. Probably anybody can look into it. You can just clone it, and you can just you can just uh, clone it, and you can just give Docker Compose. All you got to do is you got to have Ubuntu Box plus Docker Composer available. So once you just uh, spin it up right, the things would work at ease. With that said, I'll quickly jump on to the front end. Okay, so right now, right, see again, these are all secured, quite secured with cryptography. Okay, so right now I will create a new key pair. I will onboard myself. Okay, so I am one of the manufacturer. Okay, so I will onboard myself with my new pair. Okay, so this is my cryptocurrency. Sorry, cryptographic key, not cryptocurrency. This is my cryptographic. Uh, so I'll call it as Rangesh demo tuna holder. I'm holding tuna. Okay,
I
and
think
what is it?
Hyperledger sawtooth is specially for the fish supply chain management, right? Rangesh?
No, I mean that was earlier in version 2018. But now I see it being used in trade finance as well, Satish.
Okay.
Okay, so right now I'm creating one tuna holder in my name. I presume I have caught the fish. Okay, right now you see this. I'm the holder. Okay,
Okay.
okay. Now I switch. Uh, now I will turn myself into one of the distributor. Okay, uh, I'll create a public key for myself. Now Satish as distributor. So you see Satish as distributor. Okay. Now I'll switch to my crypto key, that is 03F. See, I have shown it very raw. Okay, you can abstract all of these cryptographic keys. I purposefully, I want to make you understand. So that's the reason I have kept all this cryptographic key and stuff. See, this all can be abstracted. Okay, so right now I have switched, and I'm saying like I have caught tuna fish one. Okay, okay, so this is coming from me. If you look at this, right, this has come from me. So if you just input this key, right, you can see, okay, what all activities I have done. Okay, so right now what I'm going to do is Tuna fish one. I'm going to transfer it to Satish. So this is nothing but 0293 0293. Okay.
Yeah, Rangesh, just a minute. So
Yeah.
have suggested for Shubham to track the vaccine distribution for COVID-19. I think the
Yes.
tuna fish example will aptly hold for it, because once the manufacturer generates the vaccine, I think he can transfer it from distributor to distributor.
Exactly. Yeah. Exactly. That's a good use case as well.
Yeah. And Shubham, this will establish the authenticity of the vaccine or the tuna fish. So from the proper distributor, not from the fake distributors.
Exactly. That's correct.
Yeah.
Yeah.
So
So right
now,
now,
whom the tuna fish is with me or
so
with
I
you?
have. I'll switch to your. Um. Uh, yeah.
Account.
I'll switch to your queue. Yeah. That's correct.
Okay.
Oh. Okay. Your account is 02. No, no. I think I did not transfer it. I'm sorry.
Hmm.
So my two. I'm holding this 03 F9. Right.
So
Fish
this is
one.
a private blockchain, right, Rangesh?
Yes, I have hosted it in my AWS.
Okay.
This is my private blockchain. So I'm transferring it to Satish. Okay. 02. Yeah, this is the transfer. Okay. Now I'll switch to Satish account. There you go. You see this, right?
Yeah.
So it says, do you want to accept it or not? So now, this tuna fish is in my name. Okay. So it's 03F. Once I click accept, this will get transferred to Satish, and you would see the key is getting changed now. There you go.
Okay.
You got it right. So once
Yeah.
you input this right, and again you can track from where this came in from. So this and again the point is this is quite handy and helpful in supply chain management. I wanted to start with supply chain management, and again see blockchain is not only for supply chain management. It has got the potential even to step out of supply chain management. For example, reconciliation, trade finance, where you want to exchange money, right? The cryptos sitting out there can do it instantaneously. The frameworks like Ethereum, Corda, and are all quite, Ethereum, Neo are all those quite familiar quite familiar blockchain that is there in the open platform, where you could go and you know take a turn and finance as well. And of course, reconciliation is one of the very, very commonly used use case when it comes to blockchain. But I just wanted to start with supply chain management so everybody understand blockchain plus IoT. Once it comes to food chain, right? The IoT and blockchain plays a vital role. So yeah. So with that said, right, this is what I want to demonstrate. If you could see this, right, how did this, how it got changed. I was the owner. If you could look at the transfer of asset, right, you could easily track from where it went upon. That being said, I think we are running on top of the hour. I'll just take up any questions if you have.
Yeah, just to add to this one, so now Rangesh has generated the data. So the same data can be generated using the IoT devices. So and normal
Yeah,
microcontrollers can't be used for blockchain technology. So we need to go with the microprocessors like BeagleBone or Raspberry Pi, or we have some other Tinker OS board or Omega boards where we have a operating supported operating system to transfer the data. Right, Rangesh?
that's correct. That's correct, Satish.
Yeah. And we have some questions from KMJ. So this is with respect to the validator, whether validator 2 will also have TPs and have something. This is one, and another is if validator is not interested to get updates and run validation of transaction, then.
Okay. So yes, to answer your question, validator will have TP. If you don't want the update of other transaction, no, that is not the intention, right? Because uh, the purpose that you come and join the network is you want to know, or you want to understand how the transaction is getting evolved. So if you are only interested in listening uh, few of the transaction, then you have an option called as you know um, uh, you could still construct, at least sawtooth does not have that feature. But once you go to hyperledger fabric, right, you have something called as the um, private chain, where only the intended participant can listen to your transaction. Say for instance, you have three parties, A, B, C. If you don't want the transaction, if you don't want to listen the transaction that is happening in transaction from party A, but you are only interested to know about the transaction that is happening in B, you could opt it. But Sawtooth does not support right now, but you have it in Hyperledger Fabric.
Yeah, yeah. Thanks, Rangesh. So just to add to the security point of view, so blockchain is mainly for so with IoT perspective. So we have security. So that is the one thing. So let me share my screen. Just I will stop your stream.
Yeah, yeah.
Yeah. So for IoT, we have the security challenges. One is confidentiality, integrity, and availability, and non-repudiation. So these are the four problems with blockchain we can address in the IoT. So if we say confidentiality, so this is something which plays with the data security. So where Motu wants to, so I have taken the Motu and Patlu characters from here, so which is a famous cartoon show for kids. So where Motu want to transfer some data to Patlu, but in between John wants to hack the data or wants to see the data. So confidentiality is something which no one should see the data. And integrity, so if when someone wants to transfer data to Patlu, so the hacker wants to manipulate the data, so that is integrity. And availability, so when Motu wants to uh, transfer the data to Patlu, he is making the server down, so denial of service, that is one of the attack. So where we have, so the availability is one of the thing. And non-repudiation, so this is the main feature of the blockchain, where no one can deny that if you have sent a record or if you have sent a transaction, no one can deny that you are not the person who has done that one. So suppose if Motu wants to send a data to Patlu, so he can guarantee that it is Motu, because blockchain uses the public and private algorithms, cryptography. It uses effectively for to address the non-repudiation. So if you see the similar IoT architecture, so we have IoT devices at the bottom layer, and we have a gateway, and we have a database at the cloud level. And we have the dashboards, either mobile or any IoT device or anything. And when the same, this is the traditional approach without blockchain. And if you want to go with the blockchain, so blockchain solves this problem. So we are so the future proof way of processing your data is blockchain. So we have beautiful cryptography. So blockchain uses cryptography. So, and as Rangesh already explained, we have the beauty of blockchain is decentralization. No one owns the data. Immutability. No one can change the data. And security is because we have the cryptography and consensus and transparency. So this is the another beautiful feature of blockchain. And we have a lot of blockchains available here. So basically, we will concentrate on Ethereum, Hyperledger Fabric, and IOTA. And Bitcoin is not a blockchain; it's implemented on blockchain technology. and invented in 2008 by Satoshi Nakamoto. So he's the one who changed the we see the perspective, we see the data. And when it comes to blockchain, so we have three CIA triad, what we call in the security terminology: confidentiality, so integrity, and availability. And if we take the three, the public blockchains, the Hyperledger, if you see confidentiality, Hyperledger and IOTA can be can taken care, because Ethereum is a public blockchain. So all the data, whatever is there in the Ethereum, it is exposed to the public. So and you should encrypt it if you don't want to expose it to the data. And all these three triads, CIA triad, can be addressed using the blockchain. And as I said, this is the traditional approach. I think Shubham, you can concentrate on this one. So we have IoT device transferring data to the gateway. So where we can have a Raspberry Pi and that talk to database. So the entire structure will be same, and except the only database part will be replaced in blockchain. So all the data is stored in the blockchain instead of a regular database. So how we can achieve this one? So at the ground level, you can have a IoT device with a microcontroller and a temperature sensor, and that you can transfer it to a Raspberry Pi or any edge computing device which is powerful, such that it can talk, it can generate the cryptography, security keys, and it can store the data in the blockchain. And the amount of storing the blockchain data into the blockchain is minimal, so no need to worry about the processing data. So it takes some seconds, and it will store the data in the blockchain. Later the consensus will take care, and it will they approve the record. And at the edge, so same, you can have a microprocessor to get the data from the blockchain, and you can display it in the normal IoT devices. So when to use blockchain? So this is most important. So blockchain adds a overhead to your application. So when we should go for Ethereum, when we should go for Hyperledger, and when we should go for IOTA. So this is something which you need to decide. Ethereum is a public blockchain, Hyperledger is a private blockchain, and IOTA is a both. You can use it as a public and private. It is also a public blockchain. And this is something so which I want to cover. And next week we have there is a hackathon going on in the IOTA. So where you can so integrating everything with IOTA hackathon. So you can participate this hackathon using the IOTA protocols. You have the documentation available here where you can use it easily for integration with your IoT devices and participate and submit your use cases. So we have till November 25th is the last date for this one. And next week we are going to cover how we can integrate IOTA with the IoT. And you can we will try to come up with some examples how to integrate the data on this one. So you can participate this, and you can get a cryptocurrency. So all the winners will be getting a cryptocurrency for this one. So if you see the prices, so you will get 4,000 USD in IOTA and IoT devices and IOTA developer course, which will be free. So this is sponsored by IoT to Tangle. And IOTA and IoT exist together in the coming technology. So it's good to go with that one. And hope, I think we are running out of time. So it's 1 hour. So next session, next week, we are coming up with IoT to Tangle. And in the coming sessions, as Rangesh promised, this is only an introduction section. So we will coming up with Ethereum, how we can integrate IoT devices with Ethereum and Hyperledger too. So hope if Rangesh has some time, so we can have an hands-on session as well. What do you say, Rangesh?
Sure, Satish. We
Yeah,
can do
so when
that.
we have time, I think it's good to share some hands-on how we can create an instance in the Amazon, and how we can deploy the sawtooth. And this is a tuna fish is a good one to start, and we can imply to anything.
Yeah, that's true.
Apply to yeah. Yeah, I think we have addressed almost all the questions from Shubham Gupta and from Durga sir and Kadal sir also. For tuna fish, as it's costly, we are tracking it, sir. Sir, normal fish is not required. Yeah. So that's all. So Rangesh, anything from your side? I think you're yet to share the resources. Any learning good resources for our members?
Probably I'll drop you a mail. Is that okay?
Yeah,
I
drop me a mail and I will update in the description. So you can check the
sure.
description, and you also promise to share the code as well. So if you can share
Yeah,
the code,
I'll put it
then
in my GitHub. Yeah, so folks can just clone it out.
yeah, yeah. So okay, yeah. So thanks, Rangesh, for your nice presentation. Hope we'll be meeting soon in the next coming up sessions.
Yeah, sure.
And
Thank you. Thanks.
yeah, please subscribe to the channel for more upcoming sessions on IoT and the latest technology. So IoT doesn't exist alone. So it needs AI, ML, blockchain, AR and VR, and quantum computing coming days. So IoT needs these are the foundation. IoT is the foundation for all those things. Yeah. Thanks. Thanks, guys. Thanks a lot. Bye bye.